Let's look at 7.3 thermal inversions. So thermal inversions look like this. You can see this distinct layer right here, and that's the inversion. This happens a lot in California, Seattle, like we're looking at, some places in Utah, places in front of mountain ranges usually. So temperature does what as altitude increases? Decreases. So remember this little graph? We looked at it earlier in this unit as well. So as we rise and get higher, the temperature gets colder in the troposphere. We're just looking at troposphere. So what usually happens, warm air will rise, cold air will come down, and there is naturally this vertical mixing that happens. The sun warms the surface heats up the air moves up and radiates out, and it mixes and gets into the wind currents and moves it across the whole world. When an inversion happens, the layers are trapped, like kind of in a sandwich, and the vertical mixing isn't able to happen. There's some cold air pushing it down, and it can't get out. So look at it here. We've got the cold air up high, the warm air down low, but in inversion it's flipped, and the cold air's down here, and the warm air's up here, and the cold air's not rising, so it just circulates and circulates down here with this kind of lid on it, making the air quality worse and worse and worse. In normal conditions, it would escape out and be circulated throughout the world, like I said. So officially, a layer of warm air gets trapping cold air beneath it. The pollutants are stuck in there, and this happens a lot in valley areas. So the valley, Simi Valley in California, big place for air pollution. This inversion causes it. So you've got cold air, warm air, and cold air. So it's sandwiching it in there. That warm air is trapped. It can't rise up out of the cold air layer there, and so all of the pollutants just cycle in here. If you're doing the simulation I assigned you online at that learn.concord, you simulate this and you can see what happens with all the pollutants. Make sure you're doing that. All right, so why do we get inversions? Well, usually we'll get a warm front with high pressure, and if it's in front of a valley or an area where we get upwelling from the ocean, like our coastline in California. So whenever the radiation from the earth is greater than the radiation received from the sun. Whoops, I didn't want to do that. We get it at the poles during winter. Inversions are almost always present, but only over land areas. All right. So the ocean will retain its heat, so it doesn't really get an inversion like we do on the land. And it's usually, like I say, in front of these mountain ranges in the valley portion. There's 2 videos. Please watch them. It talks about the inversion layer. And another guy is going to talk about it for the National Weather Service. So make sure you watch that video as well. All right, that's not a lot. So make sure you watch these videos, know exactly what it is, what causes it, and you'll be golden for this lesson. See you next time.